Hey guys, in today's video, I'm going to teach you how you can automate claim management using AI agents. This workflow could help your team save hundreds of hours every year. We are going to be building a claim adjuster agent that will take a claim for a property damage, evaluate it against your internal policies, that will then come up with a claim decision on how much to reimburse, if there are any things that should be investigated further, and with justifications on why certain things are excluded. This is not about replacing your team entirely, it's to help them handle more claims faster. If you would rather have someone to implement this for you, you can book a meeting with me below. I've been building AI agents for companies making 7 to 10 figures, from onboarding agents, sales agents, or marketing agents generating leads every day. I'd be happy to implement them for you as well. So now let's go over the actual tutorial. Cool, so this is the program for today. We are going to go over 3 main sections. The first one, I'm going to show you how you can make your data LLM ready. So what this means is how can we actually turn a claim or your insurance policies into data that we can actually search and query. This is part of a process called data vectorisation, and I'm going to show you how this works. Step 2, we are going to create custom tools to actually query those databases. So the claim documents that we are going to be receiving from our clients, as well as your claim policies, I'm going to show you how we can query those databases and why this is important as part of your workflow. And then finally, we will connect all the pieces together using AI agents. We will evaluate all the information from the claim against internal policies, and then finally come up with a claim decision on what has to be reimbursed, the task list for your claim adjusters, as well as justifications coming from the actual insurance policy to explain to your customers why certain things are excluded. Here's a more in-depth view on how the agents would work. So you will receive a new claim, so property claim in this case, as an input. Here's an example. So we have claim information, property information, description of loss. It's going to extract the insight from the claim using the custom tool that we will build. Then it's going to extract the insight from the insurance policy and match. In this case, we have a severe storm with high winds that caused some damage to the roof. So then it's going to look up into the insurance policy, the different sections that are relevant to evaluate the amount to reimburse, the conditions for the reimbursement, and so on. So it's going to compare the claim to the insurance policies. And then finally, it's going to come up with a decision on the amount that has been approved, on the amount that needs to be investigated further, and a possible amount rejected. Finally, it's going to generate a task list for your team to complete the process entirely. What's interesting in this agent is that we're not assuming that the technology will tackle everything, but it's going to mash up the work with everything that is obvious. And then every time there's something that needs to be investigated further, where your team will have to ask for follow-up questions, so more pictures or more context about specific damages, then this is going to be generated automatically. Then finally, the output will be the claim decision, which is the report that you just saw. So this is the workflow. So fairly straightforward. But before we dive into the agents, like I told you, the first section now is about pre-processing the data, and I'm going to show you how this works. So now let's go over step 1, which is making the data LLM ready. And we're going to go over two steps. The first one is parsing documents. So if you have a PDF like this one, where you have tables, you have the logo at the top left, signature, and so on, all of this information, if you were to copy paste it into a Word document, you would probably notice that a lot of the information gets lost, is messy, and is not going to come out structured. This is why we're going to be using a technology called OCR using docling. Docling is an open source library that is free to use. So we're going to be using it to actually convert a PDF, so in our case, the claim and the insurance policy, into a simple text document. And the reason we're doing that is if you are to query the information and you want to find information in a specific section of your insurance policy or in a specific table, you actually need to simplify the data from your PDF. Docling is great at that because if you look at an insurance policy like this one, it's going to be able to extract the text, right, which is probably very straightforward, but it's going to maintain the visual layout and the hierarchy of the information. So then once we're going to be querying with the LLMs, the insurance policy, it's going to remember that dwelling coverage A is under section 1, that the deductible is under this section. And this is super important because when we're going to be querying the data, it has to keep this context in mind. Otherwise, it's just going to regurgitate a lot of random stuff. So this is why we use document parsing. So here is how this works. So we have this first step, which is using docling, so the document converter. And we're going to be using the claim form. And then we're just going to convert it into Markdown. It's basically the simplest format. So if I just do it again, as you can see, it's running right now. It actually converted the information from this document, which in our case, for the purpose of this tutorial, is fairly easy. Now that we have parsed the document, we're going to be able to vectorize this information. And for this, we're going to be using llamaindex. llamaindex allow you to parse documents, but also create vector embeddings. Vector embeddings are converting the text that we have into vectors. And then this is going to be the fundamental piece that will allow us to then use LLMs to query the data from the documents. I have more in-depth tutorials on how this works using Pinecone, a vector database. If we just go over the code, you're going to use this vector store index class from llamaindex. So we're going to be using the OpenAI vector embedding model called text embedding 3 small, which is the most recent one, which is fairly efficient. And here I'm converting the text into chunks. What this means is when we're going to be asking questions about the claim document or the insurance policy, it's going to create one vector containing 512 tokens. And then it's going to return me the most relevant token based on my query. So if I am asking what is the claim number, it's going to look up for all of these chunks where the claim number might be found. Finally, I'm creating the index and I'm saving it here as insurance index. So as you can see, it's already there. It's already created as part of this tutorial. So those are the vectors for the document. And this is the text of the document. So you basically have everything stored here. In this case, everything is stored locally, but you could store it in the cloud using a library like Quadrant, Pinecone, Supabase. There are many other vector databases that you can use. But in this case, we're doing it locally. Like I said, I'm creating the index with the document, which is conversion results. So conversion results is this text that has been parsed. We are converting the conversion results text into an index collection. Okay, so let's try to query it. What are the damages to the roof? Give me the value of the repairs. So here, in case you were wondering, I am just vibe coding my way around Jupyter Notebook. I use the company called Aqua. So Aqua is AI native dictation. They are the sponsors of this video. What I love with our product is that it's not only just converting audio into text, but you can actually give it instructions on how to update the text. So if I am to modify this, there's a very fast shortcut. So here, all I want to say is what are the damages to the roof and give the value of the repairs, rephrase that as a simple query, take this into account. So now it's taking up all the notes. So it edited itself automatically. And so here, if I just press start, now you can see that the damages to the roof include torn off shingles due to wind damage, and the cost of repairs are 8,500. So here, we basically did something quite cool, which is using our voice to interact with our claim document. Some other cool stuff that they have is you can actually have custom instructions. So if you draft an email, you could actually specify how to sign it. Also, what's something that is fairly common. In my case, with crewAI, it's very poorly transcribed with other tools. So I could actually add it to a dictionary and then it's never going to get crewAI wrong ever again, which is quite cool. I will add a link to their website in the description of this video. So now that we've done it for the claim document, we can do the same for the insurance policy. So in our case, it's fairly straightforward. All you would have to do is go and change the path here, rename the index collection. It doesn't make any sense to go over this again, but it's exactly the same process. You would just change the path of the document and you would just rename your index differently so that things are not stored in the same index. You need to keep things segregated so that you can compare them more effectively. Now I'm going to show you how with those collections you can actually create RAG pipelines and why this is important as part of an agentic workflow. So now we are done with step one, which is making our data LLM ready. We have the claim and the insurance policies that have been vectorized so we can query them. So now I'm going to show you how we can create tools for our agents to actually call those collections based on the task they need to perform. So the way this works is I'm going to go over the code again. So this is the claim tool. So this is the tool that our agents will be using whenever they have questions about the claim. I have more in-depth tutorials on how crewAI works, but just agents in general. A best practice when you build tools with AI agents is to structure the input you're going to pass to the tool, but also structure the output of the tool. This is going to just make it more robust and make sure it doesn't break, but also make sure that the data that gets outputted from the tool is actually usable by your agents. So in this case, the document query input is going to be the query. So this is the question about the document. So in our case, if the agent has any questions about the claim number, the damage details, the repair values, and so on, this is the query it's going to pass. And then the output is going to be the answer to that, right? So just like I showed you in the Jupyter notebook, but then it's also going to add the source text. And the source text is super important because in the case of claim management or any other sensitive document handling, you need to make sure that it's auditable and you want to go back to the relevant sections to actually figure out if there are any issues. We're using schema to structure the input, which is the query. Then we're setting a set of parameters whenever we run the tool. The model is just going to be GPT-4o. Here, we are basically saying that every time we're going to query the database, it's going to return the 3 most relevant chunks of text from the document. You can set this to whatever you want. Then here we're initializing the index. Another dimension that is important in those tools is, just like I showed you with the Jupyter notebook, here we are querying the information, but there is no specific set of guidelines on how we should actually return the data from the database. So here, what we're doing is telling the LLM, so OpenAI, how to return the data. So if we have a query about what are the damages and we want the LLM to tell us in bullet points, then you could just mention it here. This is basically how RAG works. So if I'm not mistaken, RAG stands for retrieve, augment, and generate. So the way RAG works is it's going to convert the query into vectors, and then it's going to return the most similar vectors. So if the query is what is the claim number, then it's going to return the vectors that are like the most closely associated to the claim number, right? To the query string. So what is my claim number? And the context string is actually what is being returned. So here we're giving a set of instructions where we're saying context is, those are 3 chunks that will be returned from the database. So like the claim document, and this is the query. And so here basically we're saying augment. So augmenting means that we are adding the query, we're adding the context, and we're giving a set of guidelines on how to evaluate all of this together. So we're having like a clear separation between what is the query and what has been returned from the database. And then the last thing is generate. And by generating, it's taking all of this into account to then return the final output, which is going to be like the reply from the database. So I'm just going to show you how this works. So if we are to just play around with this tool a little bit, so what is the claim number? What damages were reported? Those are like just 2 queries we're going to ask the database, right? Let's try it out. Okay. So this is how the data has been returned. So significant damage to the roof and exterior. And this is thanks to the prompt guidelines that we have here. And then it returned the information. Similarly, for what was the date of loss? The date of loss was February 28th. Cool. So now that we have done this for the claim, we can do it as well for the insurance policy. It works exactly the same way. So we're structuring the input, we're structuring the output. We're actually calling the tool differently to make sure that the agent can call it. What's different here is the set of prompt guidelines. So whenever it's going to actually augment and generate, we are giving more guidelines on how it should return policies. And the reason this is coming from a lot of trial and error interacting with this database. With insurance policies, you really need to like keep the semantic meaning of damage types. So hail could be like a severe storm, but it could also be explicitly mentioned in the insurance policy. So at times you actually need to steer and try different ways to make sure that the database is actually going to return the most relevant chunks of the policy to ensure that we're not missing out on anything when we're asking about specific damage types to figure out if they're covered. So let me just show you how this works as well. So we're just going to call it policy query tool. So is there a specific maximum coverage amount for the fence damage caused by falling trees during a storm? Now it's going to ask this question to the insurance policy, and then it's going to return the most relevant chunks. Perfect. So now it's structuring the output in something that would be reusable by the agent, right? So it's pre-mashing the work, which is quite nice. So relevant policy sections will pay up to $500 for the removal of residence premises. It's doing some analysis with important conditions. So it's basically going to return all of this output that then the agent will be able to use. So if we look at the insurance policy and we tap 500, if we're looking at it like debris removal, it looked up the additional coverages, right? So it's returning your tree fell by the peril of windstorm. So it's actually like looking into this contract carefully to figure out the possible conditions that must be met. And this is going to be used by the agent to then come up with a claim decision later on, as I'm going to show you in the section 3 of this video. Great. So now we are at section 3, which is going to be where we connect all the pieces together. So we're going to build some agents who will perform certain tasks, and they will have access to all these tools that we've just created to come up with a claim decision. So to do that, we're going to be using crewAI. crewAI is just a framework to connect all the agents together. I have more in-depth tutorials on how this works, but basically you have an agent who will perform a certain task, and together they form a crew. Let's just go over quickly how this works. So like I mentioned, it's taking basically a claim, and then it's going to analyze this claim. It's going to compare it to the insurance policy, and it's going to generate a report. So in our case, we have 3 agents, one focusing on extracting insights from the claim, one extracting the insights from the insurance policy to compare the claim to the insurance policy, and then one last agent who will come up with a claim decision. So basically consolidating all the information. So let's just go over the code now and see how this works with crewAI. So we have this first agent called claim processor, and we are defining the goal for this agent. So like I said, this agent will use the document query tool. This tool is basically gonna allow this agent to figure out this information about the claim. So the incident description, incident date, the different stuff that were damaged. Then step 2 is a policy processor. It's basically the same. So you're going to call the policy query tool. You're going to construct a query, and you're going to basically figure out and ask the insurance policy whether each damage and each repair is covered by the insurance policy. And then finally, we have the insurance adjuster agent, who will come up with a claim decision. Now, the task for each agent, so the claim processor task is performed by the claim processor agent, right? So in our case, we have one agent, one task that will be performed. And here I'm just basically telling the agent how to perform the task and which order. So fill out the claim with the relevant information. You can call this tool. And then I have basically like edge cases. And here, as you may notice, there's this output pydantic. And this is really important when you work with agents to make sure that the data is consistent and more usable across different agents. You need to define the kind of output that you want to generate from each agent. In the example that I showed you, we have this pydantic claim. So claim object is this one. So the claim object contains an incident object, a list of damage objects, and a list of repair objects. Here is a more detailed breakdown of each of these objects. So damage is damage type. So whether it's like the carpet, the roof, the fence, with the description, the estimation of the damage, whether it's covered, the coverage amount, and the supporting documents, right? I'm doing the same bit for repairs, and I'm keeping both segregated to avoid double counting between what has been damaged, what actions have been taken to actually prevent further damages, what has been repaired. So in our case, repairs are every time there's a contractor who intervened to fix something, whereas damages are more like anything that has like residual value or an actual market value. And then finally, the incident is just consolidating the key information from the claim, right? So like date of loss, date reported, claim number, and so on. I'm also generating an output file called claim markdown. This is just for me to review and debug better. So this is like the pydantic output. So in our case, we have the claim number that has been returned. Then you have a list of like damage type. So damage type, you have fence damage, the description, structural damage due to large tree branch falling on the backyard fence, damage estimate 1200. So if we go over here, you can see fence repair contractor estimate 1200, right? The first agent is focusing on basically this part, which is figuring out all the information from the claim document. So the damage description, the damage estimate, damage type. And then the second agent, who's going to actually compare the claim information to the insurance policy, is going to be responsible for filling out information about whether it's covered or not, right? So it's going to be a Boolean value, true or not, or none, actually, as a default value if it's unsure. The coverage amount. So the coverage amount, at times in the policy, you may have maximum coverage. So it's actually going to come up with how to calculate the values. As you can see here, I'm not asking for a specific float value because at times there's a lot more that comes into play. So it's actually coming up with a string. And then supporting documents, this is just returning the chunks or like the relevant sections of the insurance policy so that your team could actually go back to the relevant sections whenever they need to. And then finally, I'm defining also a claim object just to make sure it performs better. It's maybe not super relevant when you have a structured output, but in the last case where we have the claim decision task, I'm the kind of report that it should generate. So it should generate a summary of the claim decision with the incident details, a list of tasks whenever like the coverage is unsure, to tell your adjusters what actions they should take to handle these claims. Finally, this is where we're connecting all the pieces together. So we have 3 agents, claim processor, policy processor, and insurance adjuster, and they are going to be performing this task in this order. So this is important, especially if you set up your process to sequential. So the first step is to collect the information from the claim. Then the output of that is actually going to be passed to this policy processor. And then the output of this one is actually going to be provided to the claim decision task. Finally, to kick off this crew, you use this function kickoff, and then it's going to kickstart the crew. To make it more digestible, I've also created a Streamlit UI. So I'm just going to basically kickstart the crew using this. So let's try it out. So now it's initializing Streamlit. Perfect. So now I'm just going to press start, and it's going to kickstart the process. I'll be back once it's done. Awesome. So this is the output of the agent. So as you can see here, we have the structured output. But what's very interesting is like the final report. We can tell like the amount that is covered and also what is not covered. Perfect. So over this video, we learn how to make your data LLM ready, how to create custom tools for your agents to actually query that information. And finally, with crewAI, I showed you how you could orchestrate a full agentic workflow to help your insurance adjusters figure out what is actually covered, what is not covered, but also generate a set of tasks for them to go through. This could help you handle 100 times more claims by cutting down the time it would take your team to handle all these things. This use case can be applied to so many other industries, KYCs if you're in banking, or even like shipping documents, lab testings. As soon as you basically have a form that you need to compare against a set of guidelines, this is a workflow that you could implement. You could take all this code and do it yourself, or you could just reach out and I will help you figure out how to best implement it. Thanks again for bearing me through this entire tutorial. And I'm going to see you very soon with another tutorial on how to implement AI agents into your business. Thank you. Ciao.